Hello, my name is Matthew Wilde. I'm a graduate student at the University of Washington, and I would like to briefly highlight results of our recently completed survey, CGM squared. CGM squared stands for Cosine Gemini mapping of the CGM. In paper 1, we introduced CGM squared and focus on the extent of the circumgalactic medium traced by neutral hydrogen. Please check out the archive for the most recent preprint. CGM squared is comparable in design to its predecessors Cos halos and Cos dwarfs, but is roughly a factor of 5 times larger. The H1 CGM squared catalog consists of roughly 600 spectroscopically confirmed galaxies that line the foreground of 22 quasars. An example can be seen on the right here, where the quasar lies in the center of the image and red circles represent spectroscopically confirmed galaxies. This provides us with a survey of impact parameters complete to 1 megaparsec and to 23rd magnitude. We assigned a galaxy to an absorption system by associating any absorption in the QSO spectrum if it's within 500 kilometers per second of the galaxy's systemic redshift. I want to briefly highlight some of our empirical results here. We can see the mass dependency of the CGM. In this plot, the blue points and red points are detections or hits, while the smaller gray points are non-detections or misses. The misses correspond to cases where no absorption above our column density limit of 10 to the 14 was found within our 500 kilometers per second velocity window of the galaxy's systemic redshift. So we can use this covering fraction, seen in the gray boxes and corresponding to right axis in the model, to model the presence of neutral hydrogen. We see a correlation of both covering fraction and column density as a function of mass. Galaxy morphology is highly correlated with mass, and so we only focus on galaxy mass for the remainder of this paper. In order to quantify the extent of the CGM, we focus on the radial profile seen here in physical impact parameter on the left, as well as normalized impact parameter on the right. Leveraging our large sample of galaxies, we subdivided our analysis into 3 mass samples with approximately 200 CGM systems in each sample. The low mass sample corresponds to galaxies with stellar masses below about 10 to the 9 solar masses, while our high mass sample corresponds to galaxies with masses larger than 10 to the 10 solar masses, leaving an intermediate sample in between. In order to better characterize the CGM, we'd like to find a reliable estimator of the extent of the H1 CGM. So if we recognize the fact that covering fraction is a probability, then we can ask the basic question, at what radius is the probability of finding gas with a column density greater than 10 to the 14 greater than 50%? We will define this radius as R14 CGM. And please see the paper for more details, but in short, we model the chance of finding gas as a Poisson process, apply a Bayesian treatment to the 3D galaxy clustering function to model the radial profile of the CGM. So here we see the results of this modeling for a high mass galaxy sample. The rug plots seen on the bottom and top of the plot on the left denote the measurements of the misses and hits respectively, which generates the sample of our radial profile seen as blue lines. So the black crosses are analogous to the gray boxes seen in the previous plots. And we see the probability of finding gas decreases as a function of impact parameter. So using our model, we can solve for our CGM, and I've indicated on the plot where the median impact parameter of the sample is greater than 50%. We carry out this analysis on our 3 mass samples, allowing us to characterize the extent of the CGM as a function of mass. And we find that CGM may be truncated for low mass galaxies. If we look at the top plot here, or looking at the normalized RCGM in the bottom plot where we normalize by the virial radius, we see that in all cases the CGM extends past the virial radius, especially for intermediate mass galaxies. In an upcoming paper, we will use a more sophisticated model to investigate this mass dependence of the CGM. But for now, we can conclude that the virial radius underestimates the extent of the CGM, especially for intermediate mass galaxies, and that the CGM appears to be truncated around dwarf galaxies. Thank you very much for your time.